Let's look at 133, very similar to 132 and 134. You're given a power series here, but you're not really given the formula for the coefficient C sub n. And you're told that this power series converges for x equal 5. Okay, now let's talk about the convergence of power series. What exactly do we mean? We mean what values of x make this series convergent. It's called a power series because you see we're getting powers of x, in this case x minus 3, right? So this power series, we say, first of all, is centered about 3 because of this x minus 3 factor. So it's real important you understand where a power series is centered about. And the first, so when we talk about where a power series converges, there's one of 3 possibilities. And the first one is that it converges only at the point it's centered about. And by point, I mean the value of x. So 3. Obviously, if I plug in x equal 3, I get 0, right? Who cares what C sub n is, right? 0 times C sub n is 0. This is 0. N equals 0 to infinity of 0 means what? 0 plus 0 plus 0 plus 0 plus 0 plus 0 plus 0 forever. That's going to be a finite sum, right? It's just 0. So that's trivially true. In fact, every power series will always converge at the point it's centered about. Okay, at the value of x it's centered about. So some power series are only convergent there. Those aren't very interesting. Just only converge at that one point. Not very interesting. But that is one possibility. Okay. The second possibility is much better, and that is it's convergent for all values of x, all real numbers. We say the interval of convergence is negative infinity to infinity, right, in interval notation. The radius of convergence, we say, is infinity. Okay, when it's convergent only at the point it's centered about, we say the radius of convergence is 0, right? So those are 2 extremes, right? It's either convergent just at the point it's centered about, or it's convergent for all real numbers. Okay, there's 2 possibilities there. There's one more possibility. The final possibility is that there's some finite, what we call radius of convergence. Okay, let's say the radius of convergence is 7. Okay, we'll just say it's 7. Okay, for this one, we're centered about x equal 3. So what this means is radius convergence 7 means add 7 to 3 gives me 10, right? So if we're right at 3, x equal 3 in the middle. If I add 7 more, right, I would be at 10. If I subtract 7, I would be what? At negative 4, right? So I'm going 7 in either direction. And what this says, that if that's the radius of, if that is the radius of convergence, I'm not saying that is for this one, but that's a possibility, then all the values between negative 4 and 10, everything between negative 4 and 10, we would say the series converges for those values. Now, what about these so-called endpoints, negative 4 and 10? Well, it may or may not converge at the endpoints. And when you're doing the interval of convergence, when you're actually finding it later on in the homework, you then will need to check, right, these endpoints. In other words, plug in x equal negative 4, plug in 10. Look at that power series that you get and see, does that series, well, you just have a series now, does that series converge or diverge? And there you're using all the tests, use the summary sheet of tests, go down the list, right, from top to bottom till you can show one or the other. If it converges, we include the endpoint. Okay, if it diverges, we exclude it. But that's the interval convergence, but the radius of convergence is 7. So that's the case. So now let's go back to this problem. We're told only that this power series converges for x equal 5. We're not told the radius of convergence, nor can we find it because I don't know what C sub n is. So you say, well, how am I going to determine this stuff? I have no information. Well, you do. Because it's convergent at 5, right? We're centered at 3. The distance between 3 and 5 is 2, right? So here we're x equal 3. I know we're convergent at 5, right? The distance here is 2. I don't know anything else other than it's convergent at 5. I don't know if it's convergent right off the bat for values greater than 5, but I do know, since it's convergent at 5, it's got to be convergent for everything between 3 and 5. And, right, if I go 2 less, right, subtract 2, go to 1, I know everything between 1 and 5, it has to be convergent. Everything between 1 and 5, it has to be convergent. Now, it may be convergent for values greater than 5, I don't know. But the only thing I can say right now is anything between 1 and 5. Of course, that means x equal 2 and x equal 4. Okay. Now, again, it could be convergent to those values, but all we know is this, and so this is the minimum, right? This is what we have to assume. Now, what about if I notice? What if it was x equal 1 in this list? Didn't have x equal 1. What about that? Well, we know it converges at 5, but again, that's an endpoint, like we're talking about. This 1, again, we don't know. Again, it may or may not be. Just because it's convergent at one endpoint doesn't mean it's convergent at the other endpoint. So again, I would not be able to circle even x equal 1. It would just be the values strictly between 1 and 5 here that I could circle. Okay, so this is just, these exercises are just kind of a thought experiment to make sure you understand what's going on and what the possible intervals of convergence can be for a power series. And later on in the homework, you will actually find those intervals of convergence. Okay, hope this helps with number 133.